everyone. Today we are going to discuss and performing the experiment LDR characteristics. LDR is nothing but the light dependent resistance. When you incident the intensity light to that LDR, that time what happens? Its resistance going to change. High intensity means resistance decreases. Then you can say R is directly proportional to the 1 upon D. D is nothing but the distance of this lamp, means you are changing the intensity and light following on the LDR. Okay. Now also you can say R is directly proportional to the 1 upon I minus 1. Okay. And it is a very important apparatus and circuit they are using in street lights or so many applications controlling the signals and other things. Even though your door system, automatic door system and other things, the LDR plays an important role. LDR looks like this. Okay, you just see here. In between there are the lot of tracks are there and they are continuously. Okay, and whatever the light coming from this focus or lamp, that will fall on this area. That time what happens, when the light falls, that time its resistance changes with respect to that intensity light. Okay, it is the how it is look like. You just see here, these are the two terminals. One terminal is above and other is the bottom terminal. Okay, they has to be connected here. Okay, now here this is the whole setup of LDR. Okay, here is the 230 volt supply given to this transformer, primary, secondary. There are very 2 or 3 volts, and we have regulated this circuit and it converted into DC. This is the Zener diode. Okay, it is a constantly 3 volt supply you will given. 3 supply. After that you have to connect here this is the supply terminals, means the output of this supply connected here. Here we are connecting the milliammeter. After that the milliammeter positive connected here, negative here, and then it directly connected to this resistance terminal connected to here. Same thing, this is negative here connected. Here one key provision is there. Okay, and that has to be connected the second terminal of LDR. In between, ammeter connected in series and voltmeter in parallel to this LDR. We are making the connection. Here I am putting the ammeter. Here I am putting the ammeter. Okay. Now connection of this ammeter. This supply one pin is here. This is the milliammeter. It has connected to the positive, and negative of this ammeter. This negative of this ammeter, milliammeter, that has to be connected here. Okay. Connect. And after that you have to connect the voltmeter over here. Voltmeter, positive terminal of this, output of this is connected to this, and negative is connected to negative terminal is connected to the, this is the key. Okay, this is the negative for the voltmeter and its range is in DC. There are the switch. Okay, AC and DC. Right now I am putting in on DC position, and this is for the, just like as the key. Okay, now here I am putting the milliammeter and voltmeter. Okay, now first you discuss about this range 0 to 0.25 and 10 lines are there, means one line value is 0.025. Okay, now after that 0.25 again 5, means this 0 to 0.5, there are the 20 lines. Means 0.5 divided by 20 lines, the one line value will be 0.025. Okay, in this way you can measure the millimeter ammeter current measure. And now come to this voltmeter. Here up to this point, 0.5 is there. You just see here. Here you just see this is the 0.05 and 5 lines are there, means one line is 0.1. Here is the 1 volt and lines between this 5 and these are the tens. Here is the 0.1 and again this is the 0.1. Okay, so you have to very carefully taking this reading. Okay, now for this particular experiment we make the sum of the arrangement. Here is the LDR, it is a 0. Now it is a 10 centimeter, 20 centimeter, 30 centimeter, 40 centimeter, 50 centimeter, 60 centimeter, 70, 80, 90, and this is the 100. Okay, 100 centimeter distance from this lamp to the LDR, and we are just moving this in this direction. Whatever changes you will observe on that meter, you will just we will calculate the resistance, whatever the resistance changes with respect to this intensity. Okay, let us start the experiment. Right now we are making all these connection and this key is open. Now I am going to start this. Okay, and put this wire as a key. You will just see the readings. Okay, supply is started. This current, this is the voltage. Okay, 1.75 near about, and this is the near about 0.7 milliampere. Okay, now but one important thing is that whatever the light coming on, that will affect you are observing here. But particularly for this LDR experiment you require the dark room. Okay, right now just this is our dark room. Okay, now I am starting the focus. Now we will start the experiment. First we put on the light. Okay, this is the lamp. Here the distance is 100 centimeter and it has to become here. Okay, so now this distance, this is the 100 distance. Okay, I am putting here because here is the lamp, and now this is the 100 centimeter, and that light straightly falls on to the LDR, and you just see the reading. Okay, these are the readings. Right now I am changing the distance. Here is the 90. You just see here. Here is the 60, 70, 60, 50, 40, 30 and 20. Right now you just see here distance is 20 centimeter. I am putting the lamp, the distance between this LDR and lamp is 20 centimeter, and you will observe here voltage is fully reduced. Okay, and current is increases, means whenever the light falls to this, that time your resistance decreases and current increases. Okay, so you just see here again I am increasing the distance of this lamp. So you just see for there. Okay, your voltage increases, current decreases, means intensity of that light is also playing an important role. This is the circuit. Here is the supply. Okay, here is the supply to that millimeter, one resistance is there. Okay, after that key and goes to the here, and with across this parallelly we are measuring the voltage. Distance of the LDR, this lamp to this LDR, right now we have taken the distance 100 centimeter, 90 centimeter, 90 centimeter, 80 centimeter, 70, 60 and up to 12. Whatever the current you will get for this, you have written here. And this reading is converted into the ampere, voltmeter reading, okay. And after that your aim is to find out the resistance with respect to intensity variations, okay, of that light. The R is equal to V upon I, V is equal to IR. This is nothing but used as a Ohm's law. After that, whatever the distance you are taken for this particular readings, so you have to D square for this, okay. And now you are finding the log D and log R, okay. Now this is plotting the graph. Plot a graph is that whatever the distance is there, okay, D square. So x-axis you have to take the D square, and your y-axis is with respect to this distance, whatever R you are calculated by using this reading V and I. So you have to calculate this R, and the R taken on the y-axis. And when you plot the graph, that time you will observe this type of the graph. Now come to the second graph also. Now log D, log R. You have to find out the log D and log R for separate two columns. Take the log D on x-axis and log R on y-axis, and you mark the point and find out the slope. Then you will get y by x. Okay. So now here formula is there. Okay. Formula like LDR resistance. Resistance of this LDR, slope of log R against log of D. So you have to return whatever the slopes value you coming from that graph, you have to return here, and then calculate this resistance. Formula is this resistance of the LDR. How to calculate? R is equal to V upon I, and that value will become in ohm. Okay, this is the way you can perform the LDR experiment. Thank you.